Welcome back to part two. Now that we know how synthetic division works, let's see what it's good for. We just divided 3x cubed minus 4x plus 10 by x minus 1. We got the remainder in the quotient, so we could take that 3x cubed minus 4x plus 10 and write it as x minus 1 times the quotient 3x squared plus 3x minus 1 plus the remainder 9. Now question, if that's our function, what do we get if we evaluate that function when x is 1? We plug in 1. Like we're doing 3 times 1 cubed minus 4 times 1 plus 10. You can go ahead and work that out if you want, but here's an easier way. Remember, it's x minus 1 times 3x squared plus 3x minus 1 plus 9. If we plug 1 in for x, so we're doing 1 minus 1 times 3 times 1 squared plus 3, plus 3 times 1 minus 9, or minus 1 plus 9. The 1 minus 1 is 0. And this part, well, who cares? 0 times anything is 0. And then that 0 plus 9 is 9. So f of 1 is 9. In other words, it's the remainder that we got when we carried out the synthetic division with a 1 out in front. We divided by x minus 1, and the remainder we got was at f of 1. Turned out to be 9. So that fact in general is what's called the remainder theorem. If a polynomial f of x is divided by x minus some particular number k, so k itself is the number that's out in front, then the remainder is f of k. The remainder you get from the division is the same as the value of the polynomial when you plug in that number k. So for example, if f of x equals x cubed minus 4x squared plus 9x minus 13, what is f of negative 2? What do we get when we plug negative 2 in for x? We could do it the old-fashioned way, where we actually calculate negative 2 to the third power minus 4 times negative 2 squared plus 9 times negative 2 minus 13. But let's do it the remainder theorem way. We're going to put negative 2 out in front. We're going to put the coefficients 1 and negative 4 and 9 and negative 13 here. And we're going to bring down the 1. Negative 2 times 1 is negative 2. Add negative 4 plus negative 2 to get negative 6. Multiply negative 2 times negative 6 to get positive 12. Add 9 plus 12 to get 21. Multiply negative 2 times 21 to get negative 42. And add negative 13 plus negative 42 to get negative 55. So f of negative 2, we can say, is negative 55. And what about when the remainder turns out to be 0, like here? We already know that because of the remainder theorem, that would mean that when you plug in this number, you get 0. So this number is a 0 of this polynomial. And we also know that that means that the division came out even. So what we were dividing by, the x minus 4, is a factor of this polynomial. So those two things go together. A polynomial has a factor x minus k if and only if f of k equals 0. So here's a polynomial, p of x equals 7x cubed minus 3x squared plus 5x minus 9. First question, what's p of 1? Let's find it using the remainder theorem. We'll put 1 out in front, and we'll put 7 and negative 3 and 5 and negative 9 here. And we'll start with the adding and multiplying. Bring down the 7. 1 times 7 is 7. Negative 3 plus 7 is 4. 1 times 4 is 4. 5 plus 4 is 9. 1 times 9 is 9. Negative 9 plus 9 is 0. So what is P of 1? Answer, 0. Does that help you factor P of x? Why, yes. Yes, it does. We now know that we can take P of x and factor it into what we divided by, which was x minus 1. So remember, 1 being a 0 means that x minus 1 is a factor, times 7x squared plus 4x plus 9, which was the quotient. Next example, if P of x is x cubed plus 2x squared plus 9x plus 18, is negative 2 a 0 of P of x? One way to tell would be to plug in negative 2, do the calculation, see if we come out with 0 or some other number. But another way would be to do the synthetic division and see if the remainder is 0 or some other number. So put the negative 2 out in front and the coefficients 1, 2, 9, and 18 across the top, and away we go. Bring down the 1. Negative 2 times 1 is negative 2. 2 plus negative 2 is 0. Negative 2 times 0 is 0. 9 plus 0 is 9. Negative 2 times 9 is negative 18. And 18 plus negative 18 is 0. So the answer to the question is yes. Negative 2 is a 0 of P of x. Next example, P of x equals 7x cubed minus 18x squared plus 5x plus 6. Is x plus 1 a factor of P of x? Well, what do we put out in front? We're dividing by x plus 1, so the number that goes out here is negative 1. And then we've got 7 and negative 18 and 5 and 6. So start by bringing down the 7. Negative 1 times 7 is negative 7. Negative 18 plus negative 7 is negative 25. Negative 1 times negative 25 is positive 25. 5 plus 25 is 30. Negative 1 times 30 is negative 30. And 6 plus negative 30 is negative 24. So the answer is no. Negative 1, we did not get a remainder of 0. The division did not come out even. X plus 1 is not a factor of that polynomial. What about x minus 2? Is that a factor? Well, let's try it. If we're dividing by x minus 2, what number do we put out in front? 2. And we put 7 and negative 18 and 5 and 6. And bring down the 7. 2 times 7 is 14. Negative 18 plus 14 is negative 4. 2 times negative 4 is negative 8. 5 plus negative 8 is negative 3. 2 times negative 3 is negative 6. And 6 plus negative 6 is 0. So for that one, we can say, yes, x minus 2 is a factor. And that means that we can factor our polynomial into well, remember we said one of the factors was what we were dividing by, x minus 2. And then the quotient we got was 7x squared minus 4x minus 3. Now, you know what? We can go ahead and factor that the old-fashioned way. We got our x minus 2, and then that 7x squared minus 4x minus 3 is going to break up into two factors that start with 7x and x. They have to end with numbers that multiply to -3, and the outside and the inside have to combine to -4x. So what if we put a +3 here and a -1 here? Because if we FOIL that, we got 7x squared minus 7x plus 3x, so there's minus 4x minus 3. So now it's been factored completely. Now we know all the factors. We got x minus 2, we got 7x plus 3, and we got x minus 1. And for each factor, we have a 0. 2 is a 0. And then for 7x plus 3 to equal 0, x would have to be, well, 7x would equal -3, so x would equal -3 over 7. And then for x minus 1 to equal 0, x would be 1. So the zeros of that polynomial, oops, why did it skip down? Okay, so the zeros of that polynomial are 2 and then -3/7 and 1. Now this last example, I would encourage you to try on your own. Pause the video and then come back and see if my answers agree with yours. Ready? Go. Okay, did you try it? I'm going to work through the answer. I'm putting -2 out in front. I'm putting 1 and a 0 for the missing x squared term, and a -3 and a 2. Now bring down the 1. -2 times 1 is -2. 0 plus -2 is -2. -2 times -2 is +4. -3 plus 4 is 1. -2 times 1 is -2. 2 plus -2 is 0. So the quotient is given by these three numbers here. It's 1x squared minus 2x plus 1. And the remainder is 0. There is no remainder. What is p of -2? It's 0. The remainder was 0. So is -2 a 0 of that polynomial? Yes. Yes, it is. Is x plus 2 a factor? Again, yes. -2 being a 0 means that x plus 2 is a factor. And then to factor it completely, we got it broken up into what we were dividing by, which was x plus 2, times what we got for the quotient, which was x squared minus 2x plus 1. And that factors further into x minus 1 times another x minus 1, or x minus 1 squared. So that's what it looks like factored completely. So the solutions, if we want the whole thing to equal 0, either x plus 2 could equal 0, which means that x equal to -2 is a solution, or x equals 1 is a solution, or x equals 1. So x equals 1 is a double solution, a solution of multiplicity 2.